Okay, let's go over these problems 13 and 14. So here we have a lumber yard that is manufacturing and cutting these boards. Okay, now we are told that the boards are cut in a manner that makes them normally distributed with the mu of 22. So I'm noticing that's a population mu and a population standard deviation of 3 feet long. And so then we take a random sample of 60. What is the probability that the average length of the sample of boards? So that means they're asking about what's the probability of finding an X bar at a particular location of 23 feet or more. So recall, we're going to have all the individual boards and their lengths that they are cut. And so then we've got all these individual amounts. And so then here we have this where they are centered around 22 with a standard deviation of 3. But then our sampling distribution comes down where I have randomly selected 60 boards from in this population, and I get an X bar. Okay, and I randomly selected 60 boards, averaged the 60 boards. And so we know that they will still be centered. The center of the X bars is still going to be centered at 22. But they do have a different standard deviation. The standard deviation of these is not 3 like it says above. It is going to be that 3 divided by the square root of the sample size of 60. Okay, so that's how you're going to get that. All right, and then the question says, what's the probability that you get an X bar right here at 23 or more? So what's that probability? Okay, so let's take a look and see how your problems came out. So here was our population mean and standard deviation. We were told that that population was normally distributed. It had told that to us right here. Okay. And then we start giving information for that drop down sampling distribution. So the samples of size 60. And then we had, let's see, so they are centered at 22 as well. But they have a smaller standard deviation because of its samples, 3 over the square root of 60, 0.39. Now, we know that it's going to be normally distributed as well if the population is, so we do know that. Now, what says circle what this question, circle what the information in this is talking about. So this is talking about the sampling distribution. We already talked about that, so I circled this information because it asked about the average length of the samples of boards. So it was asking about an X bar. So that's why we have X bar minus the mean of X bars over the standard deviation of X bars, and we get that Z-score. And we wanted to know the probability of that being that much or more than, says more than. So I'm going to norm CDF the area above. Now, you may not have the calculator to be able to do that at home. And if you don't, that's fine. Just at least write in this right here so that I know what that will compute to be. But the question also asks what I have circled here in blue. The question also says, does this indicate that the machine that cuts the boards may be malfunctioning? So here's why I say yes. Because the sample results I got were so far out there, they were an outlier amount. And so because I got something so far out there, then I'm speculative. I'm kind of worried that the data may not actually be centered at 22. Since I think because I got this one so far out here then maybe this data isn't really centered at 22 and it may be centered somewhere a little bit higher to where the results I got were not as unusual. So, therefore, my conclusion says, yes, I think the machine may be malfunctioning. If the machine makes an average of 22, then there's only, look, a 0.5% chance of getting that average of 23 or more. So something's wrong. Something's going on. That's too unusual. Okay, there was 13. Now looking at 14, here we go. Automatic machine cuts ribbons of hot steel into bars of a specified length. So the machine is calibrated to have bars with a mean length of 20 and a standard deviation of 0.4 feet. So these are population numbers, and see that sigma? It's a population standard deviation. For a random sample of 40, so I got a sample size of 40, what is the probability that the sample mean, so I'm asking about X bars being at 20.1 feet or higher. So let's lead into this. Here we go. So, of course, the population values were 20 and 0.4. We have not been told if the population is approximately normally distributed, so that's a problem. Okay? But we then go into this. So what that tells us is we may or may not, we don't have the right to actually compute normal model math with the population. So I cannot compute about the probability that one bar is a certain length. Okay, so I don't even have the right to compute with the population data. So then I have to make a sampling distribution. And so samples of size 40, the average of the X bars are centered at 20 with this smaller standard deviation because it's the population 1 divided by the square root of 40. So now they asked what's the probability. So you have to add this in here that you get an X bar of 20.1 or higher. And so then we know it's normally distributed. Why? Because it's large enough. Okay, it was a large sample size. So that's why we knew we were good to go. All right, and then we're coming on over here. We're going to get our z-score, and let's see how that goes. There it is. And we're going to norm CDF the upper part because it wanted to know the probability of being higher. And that's all it asked for. Okay, so there's your 13 and 14. And so hopefully you're kind of getting a handle on how to do the computing of these probabilities for the sampling distribution. Even if you've not been able to do this part here on your calculator, because if you do not have that calculator, so if that's been a problem for you, you can do everything except for that. Okay. All right, so I will see you in the next video where we're going to talk about computing something with the population and see what that type of question looks like. Okay?